7 is operations on functions. So we're going to start out with the main operations, the operations you guys have been doing for a very long time: addition, subtraction, multiplication, and division. So the only thing that you need to know here is that sometimes we do a shorthand notation for f of x plus g of x, and so on. So if you see f of x plus g of, f of x plus g of x, we can shorthand it by writing f plus g of x, like that. Does that make sense?
Oh, yeah.
And if we had f minus g in parentheses of x, then we would be subtracting our two things. Chris, there's a chair over here too, if that's easier, I don't know. All right, so it says given f of x is equal to 4x squared plus 3x minus 1, and g of x is equal to 6x plus 2, find each function. So when you see f plus g of x, what that means is to take the function f of x and add it to the function g of x. So we're taking 4x squared plus 3x minus 1, and we're adding it to the function of 6x plus 2. So we just simplify just like normal. We combine our like terms, so we get 4x squared plus 9x plus 1. Chris, you gotta go sign in the front. Sorry, I just took attendance. Run down there and sign in. Okay, so then f minus g of x is gonna be f of x minus g of x. Now when you subtract, if you're subtracting functions or polynomials or whatever we're subtracting, we have to put parentheses. Okay, so we're gonna have f of x was our 4x squared plus 3x minus 1, and minus g of x. G of x was the entire 6x plus 2. So make sure you put parentheses at least around that second function. Okay, because then we know that we have to distribute that negative n. So we should have 4x squared plus 3x minus 1, and then minus 6x minus 2. So we get 4x squared minus 3x minus 3. Does that make sense? So this next one says find f times g, and then instead of x, we have of 1. So what this is saying is we're finding f of x times g of x, but we're going to plug in 1 for each of them. So really we can do f of 1 times g of 1. So you can do this in two different ways. You could find fg of x, which would be taking your f of x function, 4x squared plus 3x minus 1, and multiplying by the g of x function, which would be kind of annoying because then you have to multiply it out, kind of like FOIL, where you take the 4x squared and multiply by everything in the second polynomial. Then you take the plus 3 and you multiply by everything in the second polynomial, and then you take the minus 1 and multiply by everything in the second polynomial. Do we want to do that? No. What we would rather do is find f of 1, right? Get that answer. Find g of 1, get that answer, multiply them together. Much easier, right? So that's the way we're going to do it. So go ahead and find f of 1. So off to the side if you want to say, okay, f of 1 is going to be 4 times 1 squared plus 3 times 1. What do I get when I do this? 6, yep. And then g of 1 is going to be 6 times 1 plus 2. It ends up being 8. So we take our answers of 6 and multiply by 8, and we get 48. Much easier than foiling it all out, right? Does this make sense? Now in the division rule, we still have, it says f divided by g of x is f of x divided by g of x. We always say where g of x is not equal to 0. Okay, so our function isn't going to be defined when our denominator has an x value that makes it 0, right? So we have to talk about our domain and range. So we'll be talking about domain and range today as well. Michael, you with me? All right, so it says given f of x equals 6x squared minus x minus 12 and g of x equals 2x minus 3, find each function. So if I'm finding fg of x, so f times g of x, then that's the one where I don't have a number this time. And I do have to multiply them all out. So I have 6x squared minus x minus 12, and I multiply by 2x minus 3. So we just multiply it all out. So I'm going to get 6x squared times 2x is 12x cubed. 6x squared times negative 3 is negative 18x squared. And then I take my negative x times everything. So negative x times 2x is negative 2x squared. Negative x times negative 3 is plus 3x. Negative 12 times 2x is negative 24x. Negative 12 times negative 3 is plus 36. So our result is 12x cubed minus 20x squared minus 21x plus 36. Okay, everybody see that one? All right, and if we have f divided by g of x, we take our f of x divided by g of x. So 6x squared minus x minus 12 and 2x minus 3. And then we actually check to see if it reduces out. So everybody look up here. You cannot reduce out things like this, okay? You can't do that. Okay, the reason is because if you had numbers, like if I had 2 plus 5 over 4 plus 7, do you guys see how this result is 7 over 11? Right, is that the same as reducing that out and saying 6 over 9? No, 7 over 11 is not the same as 6 over 9. Okay, so tell me why I can reduce something like 2 times 3 over 4 times 7, right? That was 6 over 28, which reduces to 3 over 14. But I can't reduce, so if I had done that, if I had reduced here, I would still get 3 over 14. So tell me why I can reduce the top one but not the bottom one. What, Gloria? Because it was multiplication on the top one, and then what were we doing on the bottom? Like adding or maybe subtracting, same rule, right? So if you have like an addition sign or a subtraction sign in between them, you cannot reduce out. But if we can factor something, and then we have things multiplied, then we can reduce. So that's what I want you to check on this example. I want you to see if you can factor the top. Because if we end up having something that's like 2x minus 3 on the top, and we have a 2x minus 3 on the bottom, then we can actually reduce those out, okay? So I don't know, what would we need? We would need 3x and a 4, I think plus 4. Does that work? 8? Yeah, that actually is how it factors, right? Did you guys see it? Because we get 6x squared, outer is 8x, inner is negative 9x, and then last is negative 12. That's how it factors. 8x minus 9x makes that negative x. So because of that, this factor and this factor are the same, and we cross them out. So this actually reduces to 3x plus 4. Okay, so that's not always going to happen. Like f divided by g, right? That was just a coincidence that those reduced, but we should always look for it. So you should always factor the top to see if it reduces out at the bottom. Okay? All right, so now on to the kind of newer stuff. So that, I think you guys understand how to add functions, how to multiply functions, right? We get that. But now we're going to do something called a composition of functions, and it's going to look very strange. So it's going to be written like this. F, there's a little o. It looks kind of like a times sign, like a multiplication sign, but it's open. So it's kind of hard to draw with this pen. It's very open like that. And then F-O-G of x, like that. O. I feel like, yeah, you kind of spell out fog. The O is kind of like our lazy of. Like, have you heard someone say, oh, top of the morning, O? Think of that. That's what the O is. It's of. So this means of. It's really dumb, isn't it? This is how I write it. F of g of x, right? That's what we're doing. We're putting one function inside of another function. All right, so, and then it talks about the domain here. It says the domain of f of g of x is the intersection, so our overlapping shading of the domains of the solution, f of g of x, and also the domain of the inside function, and I'll talk more about that. All right, so let's go here. So when we see f of g of x, so as Becca's saying, it does spell out fog. What you're thinking is f of g of x like this. Okay. So you guys know, like if I asked you f of 7, you got that down. You're like, oh, f of 7, I take 7 and I plug it into the f function. So I'm going to have, instead of 2 times x, I'm going to do 2 times 7 minus 3. So I get 14 minus 3. So I get 11, right? You guys get that. You guys get how to do f of 7. So what if I had something like f of x squared? What would we do? We would take the x squared and we replace the x with it. So it would be 2x squared minus 3. Do you guys see that? Okay, so what is our g function? It's x squared. So that's what we're doing. We're taking our x squared and we're replacing the x with x squared. So we're going to get 2 times x squared minus 3. So it's just 2x squared minus 3. You don't have to write it in parentheses like I did. That's what the composition is. It takes one function and replaces the x with that whole function. So if you see g of f of x, so I could have written that as g of f of x, right? Same thing. I like it with the parentheses better. I don't really like the little o. I think it's silly. All right, so g of f of x is going to be g of, and then f of x was 2x minus 3. Nope. So just like if I had, think about what g of 10 would be. If I had g of 10, I would go into the g function, and I would replace my x with the 10, right? What would my result be? 100. So we're going to go into the g function, and we're going to replace our x with the entire inside part, the entire 2x minus 3. So
2x minus 3 squared.
We're going to have 2x minus 3 squared, exactly, Eric.
So that, if I'm to understand correctly, f of x equals the x in the g function?
F of x, what do you mean?
In the specific problem, you plug in f of x for the x.
You plug in the f of x for the x, yep, exactly.
Is that the case for all of these?
That is, yep. So you can leave it like 2x minus 3 squared, or if you wanted to simplify that, what would we have to do in order to simplify that? Is that 4x squared minus 9? No, right? So you'd have to FOIL it out, right? So you'd have to FOIL 2x minus 3 times 2x minus 3. Have I told you there was a Sycamore teacher that used to take money for this? Have you heard that story? Every time her students said that this was 4x squared minus 9, she made them pay her $1. I feel like as a math teacher, I would make a lot of money every time my students wrote that as 4x minus 9. That's what I found out years later. She gave the money back at the end of the year. She had a box of all the dollars with sticky notes of their names on it. And it was just a savings plan. Some of them saved a lot of money throughout the year. All right, so yes, it could also be written as 4x squared. The outer and inner is negative 6x and negative 6x, so minus 12x, and the last is plus 9. So you could also write it like that. So either way. Sorry, that's mine. All right, so then f of g of negative 1. So f of g of negative 1. So now we have numbers. These ones are always a little bit easier. So if I have g of negative 1, well, how do I find that? G of negative 1, I go to my original function. G of x was x squared. I plug in my negative 1, and I get 1, right? So on these functions, we're going to work from the inside out. So we found g of negative 1, and we said g of negative 1 was 1. So now we're finding f of 1. Well, what's f of 1? It's 2 times 1 minus 3. It's negative 1, right? So all of this is equal to negative 1. So you work from the inside out. All right, so the next one. So I have g of f of 2. So let's rewrite it. So we're going to have g of f of 2 like that. And we work from the inside out. So if you need to go off to the side and you just need to say, oh, what's f of 2? So f of 2 is going to be 2 times 2 minus 3, which is going to be 1. So then we have g of 1 then. And then you can go off to the side and say, well, what's g of 1? So g of 1, looking at my function, is 1 squared, which would be 1. So, oops, I wrote 2 now. So 1. So that means that g of f of 2 is all equal to 1. Do you understand how this process works? Yeah. All right, f of 3. So again, find f of 3. Can we do f of 3 in our head? 6 minus 3, so it's 3. And then f of 3 was 3. So this one's kind of cool because if I had written f of, I could write lots of f's. Of 3, then we get 3. Does that make sense? F of f of f. This is what we call an iterative. Iterative means repeating. I don't know, because I'm mean. All right, f of 8. Oh, I'm missing my little parenthesis there. So f of 8. So we're going to find f of 8 first. So we have f of whatever f of 8 was. So can you find it? Yeah, it's 2 times 8 minus 3, which is 13. So then we have our 13 in there. So now we have f of 13. So f of 13 is 2 times 3, or 2 times 13 minus 3. So yes, 23. So that's our answer. You guys get it? That's what a composition is. So every year people have trouble with these. So if you're having trouble, not a big deal. Just let me know. No, we're not done yet. We've got to talk about domain. All right, so it says, given f of x is equal to x squared minus 3 and g of x is equal to 2x plus 5, find the following. Okay, so you're going to find all of these different things. Do you guys want to practice and try them first? See if you can do them?
Hey, can you go back up a little bit?
Yeah. So you guys go ahead and practice. All right, so if we have f of g of x, so if you want to rewrite it with the f of g of x, like this, you can do that. And then our inside function was g of x, so what we're finding is f of the 2x plus 5. So what we're saying is we're going to take that 2x plus 5 and treat it just like our variable, our x, and we're going to replace it in the x squared equation. So we're going to have 2x plus 5 is our new x, and it's squared minus 3. Do you guys see what I'm saying? So like this x right here was replaced with 2x. This one right here was replaced with the 2x plus 5. You could leave it like that, or you could simplify. Since there's a minus 3, I would probably simplify it. So I would FOIL out the 2x plus 5 times 2x plus 5. So you're going to get 4x squared. Your outer is 10x, your inner is 10x, so plus 20x plus 25 minus 3. So I would probably write it as 4x squared plus 20x plus 22. All right, did many of you guys get that? Good. All right, so if you have g of f of x, so g of f of x like this, then we have g of x squared minus 3. So we're replacing the x squared minus 3 into the g function. So we're going to have 2 times x squared minus 3 plus 5. So we replaced the x that was right here with the x squared minus 3. All right, so we get 2x squared minus 6 plus 5. So your final answer should be 2x squared minus 1. Did you guys get that? All right, good. And then we move on to the ones that are a little bit easier with the numbers. So if we have f of g of 0, you're going to find g of 0 first. So what do you guys get for g of 0? 5. And then now you find f of 5. So now what's f of 5? 72, is that what you said? 22? Yes, 22. Yep. So you're going to work from the inside, work your way out. So we said g of 0 was 5. So we have f of 5. And then looking at the f function, x squared minus 3, we replace our x with 5. So 25 minus 3 is 22. So how about g of f of 2? So we're going to find f of 2 first. So look at the f function and replace your x with 2. So 2 squared minus 3 is 4 minus 3, which is 1. And then we find g of 1, so 2 times 1 plus 5 is 7. Do I need to write more steps, or did you guys understand this process? Okay. All right, f of 3, or sorry, not 3, 4, right? So f of 4. So our f function was the x squared minus 3. So we're going to have f of 4 is 4 squared minus 3, which is 16 minus 3, so 13. So then we have f of 13. Well, f of 13, a little bit harder, right? Who knows 13 squared? 169 minus 3, 166. That should be your answer. How many of you guys got that? You're just not going to raise your hand. You're not proud. Molly, did you get it? Molly's like, I'm not going to raise my hand. Oh, you didn't get it. Sorry, now I just called her out for not getting it. So the next one, so g of negative 2. So we're going to find the g of negative 2. So I have 2 times negative 2 plus 5 So negative 4 plus 5 is 1. So we have g of 1. So g of 1, we go back in, we say 2 times 1 plus 5, so we get 7. All right, does this make sense? Are you guys starting to understand it? All right, so the hardest part is the domain, so let's talk about the domain really quickly. So this next one says, given f of x is equal to x squared minus 1 and g of x is 1 over x plus 1 and h of x is the square root of x minus 1, write the composition of each functions and list the domain. X minus 8, yeah. I was just stuck on 1. All of them are 1. All right, so let's talk about the domains of the originals. So if you have x squared minus 1, can you plug in every single thing for x? Like, is there anything that makes it undefined? Are there denominators? Are there square roots? No. So since there's no denominators, no square roots, I could plug in anything into a t-table for x, and on the other side with my y equals, I would never get an undefined. Do you guys understand what I'm saying? That's what our domain is. So our domain is all real numbers for that one. So for f of x, we get all real numbers, so you can write it with a fancy r, or you could write it as negative infinity to infinity if you want to write it that way. Doesn't matter. So basically it's everything, all real numbers. But how about g of x? My domain is almost all real numbers except for one value that I cannot plug in. What can I not plug in to the denominator? Close. Not 1 though. Negative 1, right? Because if I plug in negative 1 into the denominator, so if I plug in a negative 1 right here, I get negative 1 plus 1, which becomes 0, and we can't have zeros on the denominator. Can't divide by 0. So this is all real numbers except for negative 1. Can't have negative 1. So if you were looking on a number line, what would happen at negative 1? There would be an open circle, and everything else would be filled in, right? All right, so how about the next one? So the square root of x minus 8. What can we not have under square roots? What's bad under a square root? Negative. So Karen? X has to be greater than 8. Close. Can it be equal to 8? Greater than or equal to 8, right? Because we can have the square root of 0. So this one is going to be our x values have to be greater than or equal to 8. Because if we plug in something like 7, then we have the square root of negative 1, right? We can't do the square root of a negative without i's. All right, so those are going to come into play when we talk about the composition of these functions. So if I find, yeah?
Is this how it's always going to be? F is all real numbers, G is...
No, it just depends on your function, yeah. So if I have f of h of x, so f of h of x was our square root of x minus 8. So if I'm finding f of the square root of x minus 8, then I'm going to have the square root of x minus 8 squared minus 1. So what do you think is going to happen there? Yeah, x minus 8 minus 1, which becomes x minus 9. Let's think about this final result. Can I plug in anything for x? Do I ever get undefined when I have x minus 9? No, right? I can plug in anything now for x and it looks okay. However, if I had asked you, so what if I asked for f of h of 7? If I had asked you for f of h of 7, you guys would have gotten stuck because h of 7, oops, 7, oh, that's messy. What is h of 7? It's the square root of 7 minus 8, negative 1. Okay, we're not going to do i's. So we're stuck.
You asked for f of h of 7, and we got, why wouldn't that come out when we squared it?
Right, it kind of would. Like he's saying, well, if I plugged it into the function above, it would come out when I square it, right? It would become, I could plug in 7, 7 minus 9 would be negative 2. But if at any point along the way, as you're doing your composition, starting in the middle, working your way out, and you had undefined, that's bad, okay? That affects our domain. So if at any point I had undefined, we're going to write the whole thing's undefined. So instead of having a domain of all real numbers, which it looks like this should be, it should be all real numbers, our new domain is not all real numbers. It has to do with the inside function.
Greater than or equal?
it's not going to be all real numbers because of the inside function. So that's why I'm going to go back here to this definition right here. So it says the domain of f of g of x is the intersection. So it's going to be where they overlap on the number line of the domains of our final result, which was x minus 9, and also the domain of the inside function. Okay, so we're not only looking at our final result, but we're looking at that inside function. Our inside function was, its domain was x has to be greater than or equal to 8, right? Can't be smaller than 8. So our final domain is x has to be greater than or equal to 8. It's a combination of the two. So it's all real numbers. If I shaded the number line with all real numbers, it'd be the whole number line, right? But then it's also the domain of the inside one, which was x had to be greater than or equal to 8. So where do they overlap? X is greater than or equal to 8. Do you guys see what I'm saying?
So it's just the domain, if you understand correctly, it's just the domain of the smaller.
Yeah, mostly it ends up being the domain of that inside one. Yeah. Okay, so if I have f of g of x, so this one, so f of g of x. So I'm going to do f of 1 over x plus 1. So when I square it, I get 1 over x plus 1 squared minus 1. We can leave it like that. All right, so our domain ends up being the final one, which is x is not equal to negative 1. That was also the inside function. See how g of x's domain was x cannot be negative 1. Well, in the final result, x couldn't also, it couldn't be negative 1 anyway. So this one is still just x is not equal to negative 1. And then h of f of x is going to be h of x squared minus 1. So we're going to have the square root of x squared minus 1 minus 9, which is x squared, sorry, not minus 9, minus 8. I was already doing the subtraction. X squared minus 9, like that. Which does not simplify down to x minus 3. The reason is because, do you guys remember what we just talked about? How the Sycamore teacher made her students pay money when we said that this was that? So going backwards, can you take the square root of this and get x minus 3? No, they're not equal to each other. Okay, so it's not x minus 3. So then we would need to find the domain of this final. Well, what was the domain of the inside? That was all real numbers, right? But the domain of the final one isn't all real numbers. Because think about if I plug in like 0. 0 squared minus 9. Does that work? No. It gives me an imaginary. So I want you to think about a number line and tell me what numbers work and what numbers don't work. Anybody have any ideas? I don't know. So we're plugging things in for x squared. So can I plug in 0? No. Can I plug in 1? 1 squared minus 9? No. 2? No. 3?
Yes.
Yes. 3 is the one I can. 4?
Yes.
Yeah. So what do we say? Everything greater than 3, right? Or equal to. How about these numbers? Negative 1? Does negative 1 work? Negative 1 squared is 1 minus 9. No. Negative 2? No. Negative 3? Negative 3 works, right? Negative 3 squared is 9 minus 9. Yep, so it's like this. So it's everything this way and everything this way. All right, so we have negative infinity to negative 3, bracket, union, bracket, 3 to infinity. That's the final domain. Okay. Does this kind of make sense? I know domain doesn't make you feel very comfortable. Your homework is barely any domain, so you can probably handle. All right, let me stop there.